Hello and welcome. Today, we're going on a hunt. We're tracking down hidden energy waste, finding its source, and figuring out exactly how to plug the leaks that are draining our wallets and our power grid.
I mean, think about it. You pay that bill every single month, but do you ever really stop to wonder where all that electricity is actually going? It seems like a simple question, right? But the answer, well, it's way more complex. And for a lot of industries, it's incredibly expensive.
Because here's the thing, a massive chunk of our global electricity isn't for lighting up our homes or charging our phones. Nope, it's powering these countless hidden engines, the electrical drives that are the real workhorses of our world. We're talking about the motors that run factories, pumps, fans, you name it. And man, are they thirsty for power. Now, this isn't just some abstract idea. The cost of all this inefficiency is very, very real. It hits the bottom line of businesses, and it impacts our ability to meet the world's growing energy demands. You see, every single watt of energy that gets wasted in a factory drives up the cost of whatever they're making. And when you zoom out, all that inefficiency puts a huge strain on our entire electrical grid. So saving energy isn't just about being green, it's about staying competitive and building a sustainable system. So to solve this problem, we first have to understand where the energy is actually getting lost. The best way to think about it is like a leaky pipe. We've got to find every single crack from start to finish. And first, let's get on the same page about what we're even talking about. An electrical drive system isn't just the motor. It's the whole shebang, the power converter that feeds it electricity, the controls that tell it what to do, and of course, the motor itself. It's this complete system where all the leaks happen. And this really shows you the whole journey of that wasted energy. Some power is lost in the transmission lines before it even gets there. Then more is lost in the power converter. The motor itself, well, it's not 100% efficient. After that, you've got losses in mechanical parts like gears and bearings. It just keeps going, all the way to how the final job is handled. It's like a cascade of inefficiency. Okay, enough about the problem, right? The good news is, we have a really powerful toolkit to fix it. So let's open it up and take a look at the first set of tools. We're going to focus on 6 key strategies, starting with 3 absolute heavy hitters. These tackle the problem right at the source, choosing the right gear, managing how it runs, and cleaning up the electricity it uses. Now, this is where it's really interesting, because it kind of flips what you'd think is common sense. People often buy inefficient motors just because the sticker price is lower, but that is a trap. The long-term electricity costs from a cheap, poorly designed motor will absolutely dwarf any money you saved up front. The more expensive, efficient motor is almost always the smarter, more economical choice. And here is another huge source of waste. Imagine driving your car with only 2 options, stop or pedal to the metal, full blast. That's honestly how a lot of industrial motors work, full speed all the time, even when the job only needs, say, half the effort. The payoff for fixing this is just staggering. By installing something called a variable speed drive, or VSD, which is basically a gas pedal for the motor, you can match the speed to what's actually needed. And the result? Potential energy savings of 20 to 40%. That is a massive number. Okay, finally, let's talk about something called power factor. Stay with me on this one. Imagine you're pouring a beer. The beer itself is the real power that does the work, but the foam on top, that's reactive power. You paid for the whole glass, but you can't really use the foam. A low power factor is like having a glass with way too much foam. You're pulling more power from the grid than you're actually using, which causes waste, instability, even fines from the utility company. Improving it means you get more beer and less foam. All right, we are halfway through our toolkit. Let's pull out the next 3 strategies, which are just as critical for plugging these energy leaks for good. These next 3 are all about precision and care. Sizing your motor correctly from day one, making sure the electricity it's getting is clean and stable, and, just taking good care of the whole system. It's a natural instinct, isn't it? When in doubt, just get the bigger one. Go for the more powerful option, just to be safe. Well, when it comes to electric motors, that instinct is totally wrong. Here's the crucial thing to understand. An oversized motor is an inefficient motor, period. It costs more to buy, it costs more to install, and it runs at a lower efficiency and a lower power factor. That means it's wasting more energy every single minute it's on. The right way to do it is to figure out the precise need and then pick the motor rated just above that, not one that's wildly overpowered.
Your equipment is also totally at the mercy of the power it's getting from the grid. If the supply voltage is unbalanced, it can cause a massive spike in current and waste. If it jumps around too much or fluctuates wildly, it just puts stress on the whole system. Clean, stable power is absolutely fundamental to efficiency.
And finally, we have good old-fashioned maintenance. Now, this isn't just about stopping things from breaking down, it's a powerful energy-saving strategy in itself. Every little bit of extra friction in a bearing, or every cooling fan that's clogged with dust, that's not just a mechanical problem. It's an energy leak, wasting power as heat and stress. So, after looking at all these leaks and digging through this whole toolkit, what's the big picture? What does this all really add up to?
Well, the benefits are huge, and they come in 3 flavors. First, there are direct, significant cost savings, money in the bank. Second, you get a much more stable and reliable electrical system. And third, by using less energy, you're obviously reducing the overall environmental impact. It's a true win-win-win.
When it comes right down to it, conserving energy in these electrical drives is about so much more than just engineering. It's a fundamental part of optimizing our resources, building stronger businesses, and creating a more sustainable industrial backbone for our future.
The source material that we've been exploring today ends with this really simple, powerful message. It perfectly captures that dual benefit we've been talking about. What's good for our systems is also good for our world.
And that really leaves us with one final question to think about. We've talked a lot about industry, but this principle applies everywhere. So whether it's at your job or in your own home, what's the biggest unnoticed energy leak in your world? And what's one small step you could take to start plugging it? Thanks for tuning in.